Hello guys, today we're going to talk about mole-mass conversions. We've already spoken about mole-mole conversions where you have 1 mole of a known and you're trying to find a molar amount of an unknown. Today we are talking about having the moles of the known and trying to figure out the mass of the unknown. You also can do that in reverse, having the mass of a known and finding the moles of the unknown. If you're looking at your stoichiometry map, this directly corresponds to the E and the A, using E and A together. So these are two-step conversions. Now, to start this problem, I've used a problem that's similar to the last video, video 4.5. This is video 5, so I use a similar problem. It's slightly different though. The question is, how many grams of carbon dioxide are produced when 17.5 moles of propane are burned in excess oxygen? Now, the question always comes up is, does that excess oxygen really matter? And the answer is no. They're actually telling you that it doesn't matter. So, for instance, when you are making corn muffins and they say that you need you have 1 box of corn muffin mix, and you have excess eggs, that just tells you that you can make as many corn muffins as the box will allow. You're not being limited by anything. So just the propane is all that we need to worry about. We've already talked about how to set up our known and our unknown. So we can put the 17.5 moles over there and the question mark grams of carbon dioxide there, or we could write it separately. It's up to you which one you do, but either way you need both the equation and your known and your unknown written together. Now I want to point out that in terms of this particular problem, this here is the moles of the known and this is the mass of the unknown. That actually should say unknown. So we're going from moles of known to the mass of unknown. Now let's pause for a second and talk. Going from moles of known to moles of unknown is path E. That is using the mole ratio from the balanced equation. Going from the moles of unknown to the mass of the unknown, that is the molar mass of the unknown. So we're going to need path A. We're going to need to figure out our conversion factors in both of these cases. So when you look at the next slide, if you will, it discusses how to find those conversion factors. So we have 2 conversion factors. Conversion factor E, the mole ratio is going to be 3 moles of carbon dioxide to 1 mole of propane. Note, whatever your known is, which in this case was moles of propane, that's what is going to go on the bottom of E. So you're always going to have whatever your known was at the bottom. Our second conversion factor is A, and that's finding molar mass. So that's taking it back to chapter 10. If you're a little stuck, you're not really sure how to do that, go back to 10.2 and 10.1 and they kind of discuss finding molar mass. But basically, you look for each element in carbon dioxide in the periodic table and you add together the masses. So since there's only 1 carbon, you add that together, you get 12.01. Since there's 2 oxygens, you're going to multiply 16.00 times 2, you'll get 32. You add those 2 together, you get 44.01 grams per mole. That gives you a conversion factor of 44.01 grams of carbon dioxide over 1 mole of carbon dioxide. So we have 2 conversion factors. We have our path E and our path A. We have our mole ratio from the balanced equation, and we have the molar mass of our unknown. In this case, our molar mass is carbon dioxide, so we found the molar mass of carbon dioxide. When we plug this in, we wind up with our known here, 17.5 moles of propane. 3 moles of carbon dioxide is at top, 1 mole of propane is at the bottom, just like in the last slide. If you're stuck and you don't know where that comes from, please rewind back and see if you can see exactly when we discussed that. We also discussed how to find these mole ratios back in, I believe, video 4. So you can go back to video 4 as well and see if you can, if you're having trouble figuring out where that mole ratio comes from. Here we have the molar mass, 44.01 grams of carbon dioxide. Now, notice that these things diagonally cancel out. And in your calculator, you'd put 17.5 times 3 times 44.01. Then you divide by what's on the bottom. Remember, we multiply all the way across the top, we multiply across the bottom, and then we divide the top by the bottom. So 17.5 times 3 times 44.01, that gives us that number. And 1 times 1 gives us that number. That's where the math is coming from. Now, in this case, the number across the bottom happens to be 1. Sometimes it won't be, so you can't just assume that it will be. That gives us 2,310.5. If we look back at our original problem, we had 3 significant figures, so our final answer needs to have 3 significant figures, and that gives us 2.31 times 10 to the 3rd grams of carbon dioxide. Now, what I'd like you to do is I'd like you to try tonight this problem. It's a practice problem. Try tonight this problem, and when you come in, this will be the first problem that we'll go over. So we have titanium 4 chloride is extracted using the following equation. And then here's the equation. If you begin with 1.25 moles of titanium oxide, what is the mass of chlorine that is released? What I'd like you to do is to first use that equation, figure out your knowns and your unknowns. It may even help you to underline them in 2 different colors, or underline it and then box if you're using only one color, like let's say you're writing in pencil. Then from there, you're going to figure out your conversion factors. You should have 2, an E and an A. Once you've figured out your conversion factors, put them into the setup and do the math. We'll talk more about it as soon as you come in next class. See you then. Don't forget to answer the question below. Bye-bye.